Hey, Amar, very impressive. First one on. Okay, I'm gonna keep letting people in here. Okay, I have 4 people so far. So who is ODI B011?
I invited him, and he and
Hey,
I don't know.
Brennan, that's not you, but is who is ODI B011? Who would that be?
He goes to our school, but he's in a different class, but he's taking.
I'm in Mr. Shook's class.
Dr. Riley. Dr. Riley. Can you hear me?
I'm just gonna keep letting people in for a little bit and then we'll start.
Hello?
So I'm in Mr. Shook's class.
Hello?
Oh, yay. Yay, Bridget.
Dr. Riley? Hello?
Okay, so I've got 1, 2, 3, 4, 5, 6, 7. Okay, let me just wait another minute or two. Up here comes somebody else. Let me see. Okay, thanks, Khadija. I think what I'm gonna do is I'm gonna post the video on our site, and then I'll just tell everyone it's there. I have like 4 people, and then you said Angie. Okay, so let me put Angela on my little list also. Okay, so I have Gabe coming in. Okay, so I have 9:02. So let me just wait another minute. I'll see who else I can get in before I start chatting. Okay, here, let me go ahead and see if I can share my screen. Let me admit 2 more people. Okay, let me just do this. Okay. Let me admit him. Okay, so it should be turning over to the screen in just a second. There we go. Okay, good. Hopefully I can still see people coming in. Okay, so what I just did a little while ago was post this key. And with the key, I kind of put little reminders. So I thought we can kind of go over that, make sure that you are comfortable with all of this, and just give you little hints for doing things. Okay, does that sound reasonable? Okay, so I think if I'm in here, I may not see your chat. So if I don't respond to something, just yell out so I can answer any questions you have. So you've got to be comfortable doing this interval notation. Okay, this kind of notation above is what your math notation was when you were in Algebra 2. So you've got to switch it over to interval notation, which means that you have parens when things are not going to be able to equal something, and brackets when they can equal something. So the trick with this is read it. This says X has to be greater than 2.5. Always, forever and ever, you want to start at the 2.5. Okay, don't start at like 3 thinking it has to be greater than 2.5. That would be the kiss of death. So start with your 2.5 and it's greater than, therefore it cannot equal it, so it's going to be a paren. Okay, and then this doesn't have a limit, so it's going forever and ever. These are one-sided domains. You have a number here, no number here. Whenever you have an infinity, you've got to use a paren because you never actually approach infinity. Excuse me, you never actually get to infinity. You always approach it because it's a concept, not a number. Okay, if I give you something like this and it's written backwards, read it from the X. This says X is greater than or equal. Okay, that's your tip off. It's going to be a bracket because it's an equality. And you're going to start at -4. It's going to be greater than, so therefore you have no limit on the right-hand side. You're going to infinity. For this next one, I call this a sandwich. And you see this a lot also in your piecewise functions. So go in the middle. Read to your left first. I just let Austin in. So this says X has to be greater than -5. So your tip off is start with -5 on the left. It can't equal it. So you're going to have a paren, but then you're going to continue because then it says X has to be less than or equal to 11. That equality tells you you're going to use a bracket and you're going to end it at 11. So it's not boundless. You have bounds on both sides. It's kind of like a sandwich. And this last one, you want to definitely know this one because this has to do with rational functions. So if you have X can equal 9, it means it can equal everything else in the world. So start at your lowest number and go up to 9. Tell me you can't equal it by putting a paren. Then jump across the 9. Start at like 9.00001 and then go up to infinity because it's boundless on both sides. Okay, so that's converting from mathematical notation to interval notation. Anybody have any concerns about this? Because this is instrumental when doing domains of just general functions and also when doing your piecewise functions. Does anybody have any question at all about doing interval notation? Let me let Christian in. Okay, anybody? Feel free if you want to have another one. I can do another one. If you want to make up one, we can make up one, but you definitely want to be comfortable with this. Some of them are boundless on one side, here and here. Some of it's sandwich. This is boundless on two sides with only 9 not being able to be equal. Let me let Tyler in. Okay. All right. So if there's nothing with this, let me continue. So here I'm going to go back into my iPad. Give me 1 second. Okay. So the next piece of this, let me see, how come this is not moving? Okay, so let me stop sharing and then reshare. Oh no, here it goes. Okay, it went. Okay, so this next little piece right in here, I say know your functions. Okay, there are 8 functions. Okay, let me just check my chat. Yes, somebody asked me to do some more examples of interval notation. Good idea. Okay, let me back up for a second and let me just see if I can get this going. Okay, so let me think of another one to do up here. What if I said, how about this, that X, let me see if it's going to write. Okay, let me stop sharing and reshare because sometimes it gets glitchy if I move it. So, okay, I have everybody in, so that's good. Okay, let me try to reshare so I can write on this. So be patient, give me a sec, and let me reshare. Okay, I think it's coming. Okay, there we go. Okay, so what if you had that x cannot equal -3 and x also cannot equal 7? What would you do? That's math notation, which is typical for algebra 2, but you're in pre-calc now. So I want you to answer it in terms of pre-calc. So I'm only omitting 2 numbers. Okay, so this is what I would do. Start at -infinity. Go all the way to -3. Don't equal it because you can't have that in your interval. Okay, so that's your first piece. Then go from -3 to 7. You can't equal either of those. That's why I have the parens. Then go one more place. Go from 7 to infinity. When you look at this, what you should see is that these values right here, these are the things that your function cannot equal. I know that by the notation because I have parens for -3 and for 7. So that should be your tip off how to set that up. Okay, let's do another one that we have to read backwards. What if I said that 5 is greater than or equal to x? You've got to kind of read that backwards because you want to know about x. So this says that x is less than or equal to 5. So if x is, so I'm going to say x is less than or equal, sorry, less, when I was doing that, less than, okay, let me try this over here. X is less than or equal to 5 when I read it that way. So if I go to 5, that's going to be my end zone, right? So I'm going to start at -infinity. I'm going to go to 5 and I can equal it. So therefore I have a box there. Okay, I'm going to put it down below because it doesn't like that. So I have a box, hold on. I have a box for the 5 because it can equal it. And I never have a box for the infinity because I can never equal that. Okay, so if I give it to you with a number in front, read it and write it from reading from the x. So x is less than or equal to 5. That means that 5 is my upper limit. So I end with 5. Because of the equality, I'm going to put a bracket there. And then where do I start? It can be less than, so it goes forever and ever to the left. So that's why I have what I have. Addison, go ahead.
So if it was x is greater than or equal to 5, would it be?
So I can't hear you. So Addison, do you have a question? Because your
Yeah.
hand was up. So if you can't say something, hold on a second, let me go back in the chat. Okay, so I can't hear you, Addison. So if you want to type what it is, I can do that. Oh, my audio is not working. Okay, so hold on. So it looks like my audio should be working. Okay, yeah, I can't hear Addison, but I can hear everything else. Let me stop sharing for a second and see if that helps.
Can you hear
Okay,
me?
so everything's on for me. Addison, try say something now.
Okay, can you hear me?
Okay, hold on, I see. I see. Okay, now try.
Can you hear me?
I can hear you now. Yeah, what happened was when I went into Zoom, for some reason it knocked my speakers off, so you can hear me, but I can't hear you. So that's all fixed.
Oh.
So go ahead.
So if it was x is greater than or equal to 5, would it be positive infinity 5?
If it's x is greater than or equal to 5. Yes. So that means you're going to be starting at 5, right? And you can equal it. And then you're going to go to infinity. So let me just share screen so you can see what I'm writing. So hold on. There we go. Okay, so let me share screen again. Because Addison has a good question. And let me just pull this down. Okay, so let's just give it a second. Okay, so this is what Addison was saying. What if x is greater than or equal to 5? I would start at 5 and then go greater. And because infinity never gets there, I'm going to put a paren, but I have to put a bracket because of the equality with 5. Okay, so good question. Okay, anything else on this interval notation? Let me let Grant in. Okay, so with interval notation, after you write it, then read it to yourself to make sure that it matches what you had above. Okay, so it's really, really, really important to understand interval notation because we're going to give you that notation when you talk about piecewise functions. So if you get confused, then we're problematic there. Okay, so let me do a couple of more because I have more people hopping in. So let me see what else I can write. How about if I say that, let's put x in the middle. Let's say it's going to be less than or equal to 51, and it's going to be greater than or equal to 20. So if I have something like that, I'm going to start with 20 and go to 51, and notice because I have two equalities, equality, I have brackets. Okay, so that's another way to do it. And then just to do another x does not equal, what if I said, let me just get out of there. If I said x cannot equal 6 and x cannot equal -1. So then what you would do is you say, okay, what's the lowest it can be? So for this situation, start at -infinity, go to -1, stop. Jump over -1, go from -1 to 6, stop, jump over 6, and go from 6 to infinity. Okay, that's how it's going to work. So when you do one of those inequalities, what you want to do is you say, I cannot equal 6, I cannot equal 1. Make sure you have parens for both of those so that you're getting close to it, but not equaling it. Okay, let's move on. So that, because we're going to come back and visit this again when we go into piecewise functions. So you've got to know these your six functions. Okay, you also kind of have to know what happens if you change these 6 functions because the parent functions are key. So why don't we do this first? I'm going to go all the way down and maybe grab an extra piece of paper down here, if I can do that. Can I add? No, I can't. So let me just go down here. So in terms of putting, let me see if I can get this out. Okay. In terms of adding different things, what I want to be able to do is do all six functions. So one function is going to be f of x equals x squared. That is going to be this. This is from that first section in your textbook that you had to read. Okay, let me just let Sophia in. So then another function is f of x equals x. So that means that you have a straight line going through the origin. You want to know that one. Another one is f of x equals radical x. That's going to start at the origin and go that way. Okay, so then you have another one is f of x equals absolute value of x. And the reason why you need to know these is because I'm going to ask you to identify some functions, but also on a piecewise function, you've got to understand these in order to make sure that your pieces are correct. Okay, another one is f of x equals x cubed. This one's going to be nice and tall, like that. And the sixth one that we wanted you to know was f of x equals the cubed root of x. And that's going to be like this. Now, you have options with this. For any of these, you can build a little t-table and pick some values and plot it. So don't think if you get to a problem and they ask you to match something up or to identify a function, don't think, oh shucks, I didn't memorize that. You are smart people. You can pick X's and Y's that will give you something to trace out and you'll be fine. And we did that in this assignment where I gave you that little t-table and you had to do that. So for example, over here, let's say you didn't remember what this was. You have the ability to do this and then get yourself this. Okay, you always pick your X's and get your Y's. And this is not, we are not in Lent. You do not need to suffer through this. Don't pick numbers that you don't know the cube root of. Okay, this is not a time for you to kind of struggle through this. Pick things that you know. Cube root, 8 and -8, greatest numbers ever. 0, wonderful. That will get you a nice graph, no suffering involved, and you'll be able to say, okay, given this graph, what's my domain? The arrowhead to your tip off, that is -infinity to infinity. Okay, that t-table is your ticket to success. Same thing over here. Let's say I totally blanked on what my radical function was. I know if I'm asking you to graph it, you cannot take the square root of a negative number. Therefore, this function is going to start here and you're set to go. If you change the function slightly, like if you say your function is instead, say, f of x equals, I don't know, radical 1 minus x. So let's say that. And I'm thinking, okay, I have no idea. I was all set when it was radical x, but now I am so perplexed. What should I do? So you could open the window and jump out, but that would be a really bad idea. So let's pick some numbers. Remember, I can't have a negative under there ever. So if I pick 0 for my x, 1 minus 0 is 1, and radical 1 is just 1. Okay, so that's easy enough. So I can see that I had to pick a negative number because if I pick anything bigger, it's going to be negative. So what if I pick a, let's see, how about a -3? And I have 1 minus a -3. So that's 1 plus 3, which is 4, and radical 4 is 2. Okay, so I have 2 points. Let's see if I can figure out what this graph's going to look like. When I have x is 0, y is going to be 1. So that's going to be right here. When x is -3, so 1, 2, 3, y is going to be 2. So that's going to be up here. So what else is going to go on? How about, let's pick 1. 1 minus 1 is 0. So then over here, I have this. So now all of a sudden, with this transformation, even though I had no clue what I was doing initially and I panicked, I picked some numbers that helped me graph it. And now I know what that looks like. Okay, you have ways out of this. You can't go in thinking I should have memorized everything. And whatever I didn't memorize and I don't know, I will have to get wrong. Bad idea. You are going in to get as many points as humanly possible, and you're going to relax and use your brain and know that you can create a very basic t-table to get you some points. Okay, so that's my big takeaway on that. Plot a couple of points, relax, and you'll be able to figure out the graph. The key is to select wisely. Notice that I had to know underneath here, it's not going to be negative. I can, no way humanly possible can I graph the square root of -1. So I'm not going to go there because I know it can't get graphed. So that's how I'm going to do it. I'm going to pick numbers that I can graph, pick wisely, pick a few of them. I don't need to have 50 numbers, and then have confidence and see if you can graph it. Okay, so that's my big takeaway on that, because when you get to doing these kind of things, unless you can graph it, you can't really do the domain the domain of it, right? I'm going to ask you domain of these functions. If it's a regular parent function, you definitely have to know it. So you want to go back and commit those 6 to memory that I just went through here. Having these 6 down here memorized is going to be important. And here it comes, because they're going to be the building blocks of everything that I can ask you. So you want to be familiar and comfortable with those functions. So even though you can't use a calculator for this, you can certainly use a calculator as you study for this so that you are comfortable with the way the X's and Y's interact. You pick an X drives the train, you get a Y. All right, that's the key thing. You've got these 6 functions, there's not 20 million functions, there's only 6. Many of them you should be very comfortable with. And those that you're not comfortable with, get comfortable with them. And then it'll make a big difference in your confidence level going in. So once you have prepared for this, it's all about mind games and your confidence level. You've got to go in being confident, but you can't be foolishly confident. You've got to be confident based on going over this material. Okay, so I'm going to come back up here and we'll kind of march through things. So for 5, 6, 7, and 8, you're going to look at what you have, and you're going to then figure out the domain and the range. Okay, so when you are plotting, the first one is your basic parabola. The second one is your basic square root. Remember, with the square root, you are starting right here. Because you can equal that 0, I have this. Okay, don't forget that that 0, 0 is a wonderful point. Now, this is a transformation of the parent function. So what's happening there is as you pick numbers, you've got to figure out what you're working with here. Let me just let Nina in. Okay, so this is going to be a transformation. It's going to be a -3, and you're going to start at -3. Why am I starting there, you might ask? Because if you put a -3 in here for the X in your little T table, so if this is a -3, 3 plus a -3 gives you a 0, and that is this point right here. Then let's take another one. I want to take a square root. So what if I take, let's see, what if I take X value of 1? The square root of 3 plus 1, which is 4, is 2. That's my second point. So when I go down to 1, so I have -3, 0. Then I have 1, which is here, 2. I have those 2 points. I'm going to just connect those 2 points. That's my shape. I can now see that my smallest X value is a -3. I can equal it, thus the bracket, and it goes all the way to the right to infinity. I found that out by plotting a couple of points because I saw it was a transformation. Okay, for number 8, this is the rational function that was similar to what we did up here for number 4. So you have to know that your denominator is your limiting factor. Your denominator cannot go to 0. So find out the 2 numbers that make it go to 0. And that they're going to be -7 and 8. So when I do my domain and my range, the only numbers I can't equal, just my domain, the only numbers I cannot equal are the -7 and the 8. I can go from -infinity all the way to -7. I then jump to the other side of -7 and go to 8. I then jump again to the other side of 8 and go to positive infinity. Okay, so what do you think about that? So I've done 5, 6, 7, 8. Say something so I don't feel like I'm talking to myself.
Wait, what do you do with the 9x plus 9 in number 8?
So
And
good
I'm still
question.
confused how you got the bottom too.
That does not really impact your domain. What impacts your domain is the numbers that make your denominator go to 0. So
So you
you can
set them
focus
zero?
on that.
Do you set them equal to 0?
Yes. So set
Oh.
each of these factors to 0. That's how I got x cannot equal -7 and x cannot equal 8. Okay, now there could be a time when the numerator matches one of the denominators and then you have a whole. We are not going to do that. So you don't need to worry about it. It's not going to be one of your questions. Your question will be like this one, where you have to just focus on the denominator, and the numbers that make the denominator go to 0 have to be excluded from your domain. Okay, we're not going to get any fancier than that. Okay, anything else about this? So definitely you want to be comfortable with rational numbers. Don't think, gosh, I hope she doesn't ask that question. She's going to ask that question. Okay, so I'm telling you right up front, you will have one like 8. I'm going to ask you to identify the domain. You can do it. You'll have to do it. All right, and it's pretty straightforward formula. Figure out what makes that domain go to 0. And like Bridget said, to get that, you're going to set each of those factors in the denominator equal to 0. And those are the numbers you want to exclude from your domain. Write this for yourself first. It gives you a roadmap. Use that roadmap to then set up your interval notation. Okay, look at the smallest number first. That's going to be excluded first. Then go from that small number to the other number, and then from that other number to infinity. Okay, that's your setup. You're always moving from left to right, from the lowest values to the highest values. And we're only going to ask you about your domain for these kind of questions. So be ready to tackle that. Be comfortable having to do maybe a little T-chart to figure out what the graph looks like. It's going to be a variation of your parent function. You can handle that by picking numbers wisely. And then once you have a couple of the numbers, you know the pattern. Okay, the pattern of a square root is going to look something like this. Okay, if you have a negative x, it's going to go the other way. But you'll be able to figure that out by plotting a couple of points and then give yourself a little mini graph and base your domain on that. Okay, it is foolish to not give yourself little pictures when you see these things. Pictures are worth 1,000 words. You don't need a big old picture here, but you do need to be able to say what you have to exclude from your domain. Okay. Okay, anything else on identifying domains of parent functions or variations thereof? So get yourself a little picture and then identify the domain. Remember that the brackets mean that you can equal it. The parens mean that you cannot. And you're dealing with x's. You're telling me about the function, but all your language, if you will, are x terms. So these are x values that I'm talking about. Okay, this next question about net change should be easy pickings for you. Okay, this should be like the low-hanging fruit. All you have to do is this. When they ask you for the net change and they give you a number from this to this, what you're going to do is you're going to say, oh, I'm going to take the f of 4 value and I'm going to subtract away the f of -1. That is the net change. And I wrote this out for you. So where do you have to be careful? You've got to be careful in the first case when you are taking 13 minus a -2. You've got to know that that minus of a negative flips it. And that's how you end up getting 13 plus 2. So a net change of 15 for number 9. For number 10, you've got to be very aware of what absolute value means. Absolute value means that you work inside the absolute value symbol first. And then when you pull it out of the absolute value, it cannot be negative ever, ever, ever. And then do whatever it says. So this says, take 2 times whatever this absolute value was, and then add 5 to it. So I did that here, f of 6, here, f of 11. Take the f of 11 and subtract away the f of 6, and you should be getting 10. Okay, that's all there is to that. You're just going to be plugging in numbers and know to take the second term minus the first term. And then you're all set. That was at the end of 2.1 in the textbook when they asked you to find net change. It was in the notes that you had to take yourself. Okay, so easy pickings. Get this one right, because it's just a question of doing a subtraction of 2 different terms. Okay, anything on 9 and 10 that I can help you with. Okay, so and you have this answer key as well. Okay, when you are doing this, we already went over this, select your points wisely. And then once you have your little graph, then you're going to tell me the domain. I will tell you now, I'm not going to ask you the range. For these kind of problems, I just want you to focus on the domain. Again, it's parent functions or slight transformation to a parent function. I'm going to ask you to do the domain. I want you to get the picture first. Even if it doesn't say, you have to draw the picture. You want to draw the picture so that you're making an educated decision about what your graph looks like. Okay, that's why we had you practice doing this. So we have you practice doing a t-table, get a graph, and then make a determination. Okay, that was the whole reason behind this. Okay, so that brings us to our beloved piecewise functions. So we have done a ton of stuff with piecewise functions. So this was 4 pieces. And the reason why we did this was we just wanted to give you one piecewise function to do, but we wanted to give you exposure to both the absolute value function here and a parabola here, in addition to your lines. Now, we're not going to tell you what the functions are. You have to recognize what they are. So clearly, if you have no power and no absolute value, these are going to be lines, okay? If you have a power of 2, that's a transform parabola. If you have an absolute value symbol, clearly that's going to be an absolute value. So when you do absolute values, you're going to have to anticipate a V shape. When you do parabolas, don't make it a V, make it a smooth curve. So those are your big things you want to consider. You absolutely want to fill in that column that says open, close. And the reason being, once you pick these numbers, you're not going to remember, I would never remember, if I should have an open circle or a closed circle. So you want to write it down for yourself so that when you are graphing your function, you look at that and you say, oh, right, it has to be open. I had to make an open circle. What makes it open? The fact that you have an inequality makes it open. When you have an equality, that's going to make it closed. When you have an inequality, that's going to make it open. Equality, closed. Inequality, open. Equality, closed. Okay, other big takeaways.
As a bitch, I mean, not as a bitch, as a girl, I low-key understand her because
Okay, so somebody has noise in the background, so just either ask me a question or repeat yourself.
to like,
Write this for yourself first. It gives you a roadmap.
I don't know, for her to doubt you, then like that's a little bit fucked up. But if you've done something in the past, then like, maybe, but, like you probably have.
Okay, so who is doing the chat and stuff? Okay, so Gabe, thank you. Okay, so other things I want to talk about, let me think about this for a second. Okay, the arrowheads are also important. If you see that X can be less than -5, that means it can go forever and ever in a less than fashion. So many times when I look at piecewise functions and this says less than, people go the other way with it. So once you do a piece, make sure that you really are doing numbers that are less than -5. Remember the number line. If this is -5, numbers that are less than it are on this side of the number line. They are to the left of that number. So be careful with that. It's very easy to mess that up by just going quickly. Okay, so pick your numbers. When they give you a whole range of numbers, use them all. Okay, whole range of numbers, use them all. Here's another one. It's one-sided. X is greater than or equal to 1, and then use your arrowhead. Another thing I really stressed in class is this. I'm going to change my color. Whatever this number is, it has to absolutely be in your table. Absolutely in your table. Not an optional thing. These numbers have to appear in your table every single time. Okay, I think we fixed that after the first couple of times of doing piecewise functions, but I wanted to just stress that.
So Dr. Riley,
Yes,
even if it says something like X is less than 1, you still want us to include the 1?
yes, because look at this first one. It says X is less than -5. I still want you to include the -5
Okay.
because you're including it, but aren't you really putting an open circle there to tell me that I can get really close to it, but I can't actually hit -5?
Yeah.
Right? So that's what you're doing. So think of it that way. It's not like you're ignoring the fact that it has to be less than that, but when you include it with an open circle, you are in fact telling me it can't be exactly equal to -5, but in this case, it could equal -5.00001. And if I start at -6, I'm going to miss a whole bunch of numbers that it could be. So just remember, whatever's in that domain has absolutely got to be in your table. That is critical, critical. Okay, and then make sure you do your Y pieces correctly. You pick your X's and then you generate your Y's. So check that over a little bit. When you use this table to generate this graph, if you find that you are violating the vertical line test and your function hits more than one place, something is wrong. So definitely go and make sure that you can figure out what's wrong. It may be that you just did one of the inequalities incorrectly, but know that I'm going to tell you it's a function. If it's a function, it has to pass the vertical line test. I'm never going to say, oh, only kidding. It's not really a function. It is absolutely going to be a piecewise function. It has to pass the vertical line test every single time. Okay, so when I do this, I know what I'm doing. I am going to ask you for both domain and range. So be comfortable figuring that out.
Dr. Riley, can you
Yep.
explain the gaps between the domain and or the range specifically, like how that works?
Yep. Okay, so when you want to do a range, you're going to start as low as humanly possible. So I'm going to hop on this first, right? So I take this from -infinity, then I had a circle here, but I had this piece here. So I actually can equal a -6. So that's how I got -infinity to -6 inclusive. I had to look at the totality of the graph. If I only focused over here, I would have had a paren for the -6. Because of this, this allows me to equal -6. That's why I have a bracket. Okay, so let's change color. Now I want to get beyond -6, but look, I have nothing in here, no Y values, none, 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 until I get to here. That's a -2. I can equal that. That's why I have this -2 right here. Okay, so then I hop on that 2 train. This way I'm not going too far. I'm going to go this way. I get up to here, but I can't go any further, so I stop. That's at +2. I can't equal it because of the open circle. That's how I'm getting that. Change color. Then I'm trying to move from here, but look, I can't. There's a gap right here. But good news, I can hop back on here, and that's how I got the 3. Then I'm going to go as far as I can. Going this way takes me further, but I can't equal that 5. So I write the 5 and I put a paren. So the 2 yellow pieces that you see horizontally going up, those are my gaps. Because I have 2 gaps, I have 2. Let me make these yellow too. I have 2 of these. They match my gaps. And for Y's, you're going to start low and then start going up vertically and see what you can follow. Okay, Bridget, go ahead.
Why is it a bracket for the -6 range if it's an open circle?
Because an open circle over here, but look over here, Bridget. See how these are closed? And this is also a -6. So I actually can handle that. So that's why I'm saying, look at the graph in totality. So when you come up here, don't say, okay, it has to be open circle until you look to your right. These are all values of 6 for Y, and they're all able to be counted. So that's why it's a bracket. Okay, that's an easy one to miss. And then is everyone okay with this gap here? I can't go to 5. I can't go to 4. This is -4, -5. I can't go to -3. Bingo. This is the first place I get to. That's where this -2 comes in. I could go this way, but I don't go too far. So start climbing up your Y this way. I get to here. I look across. Nothing is here. I'm going to have to stop right here. That's the 2 with a paren. Then I have a tiny gap. This is a smaller gap than this gap, but it's still a gap. I could hop back on the Y train here. That's a value of 3. It's filled in, so therefore I can equal it. That's why I have the bracket. Then this is going to be a short path. Go on the longer path, keep heading north, because you're heading north to stay on Y's. I can go up to here. This is an open circle though. Nothing is up here. I am stopped cold right here. That's a 5, but I can't equal it. That's why I have a paren. So on your piecewise function, you should anticipate it'll most likely be a domain like this, but expect that your range will have pieces. Okay, because that's generally what we find when we do piecewise functions. Now you've done a lot of them and you have a lot of examples, and all of my keys from either the notes or the homeworks are all up. So you can always go back and just reason it through again. Or just do this one again. This one covers all the bases because you've got the absolute value and the parabola and the lines. You have open and closed circles and you have arrows. So it really covers everything. So if you just think this one through again, you're good to go. Okay, I want to talk about the evaluation as well. So let's go up to the top of this. And let me see if it gets, I may have to unshare for a second because it's not moving. Okay, let me unshare again and reshare. And then we'll go back to that because I want to talk about a good strategy for when you are doing the evaluation. So let me just share my screen. Okay, so it's coming. Okay, I personally prefer to do the evaluation last, and I'll show you why. I've now done this entire table. So now I'm going to go up, and they want me to evaluate this. So this says, the first thing says, find the G of -6. So I go down, and I see I have a -6 right over, let me just do this, right over here. I have to look to make sure that this is closed. It is closed. So therefore I can use this one and I can say, okay, when X is -6, I'm going to use this first piece, because this works when X is less than -5, and grab a value of -7. Then go down to the next one. This says, what is G of -5? Now, this one you have to be careful, because look what you have. I see -5 here, and I see -5 here. You would be foolish to write down both 4 and -6, because you cannot use -6. It's an open circle. You don't really have that value. You have close to that value, but not that value. So this is not usable, and you're stuck with only using this one value, and that's how I have the 4. Okay, we're not going to do one like this, so don't worry about this for the time being. Let's look at G of -1. Same idea. I have a -1 here, and I don't have a -1 anyplace else, but I have to look. And what I see is that I can use this because it's closed. So therefore, my value of -1 is -2. Then go down to 0. That's this one. And I can use this one as well. I have no problem with an open circle. -1 is good. Then the next one is G of 5. Now, I don't see G of 5, but I'm going to look at my domain. This says that X can be greater than or equal to 1. So therefore, if I was going to do 5, it would be in this function. No matter what X I pick, the Y in this case is a -6, and that's how I have a -6. So I would do that last. Okay, if you like to do that first, based on this, then what I would do is after I did my whole table, I would then go back and check that. If you ever give me more than one X value, something is wrong. That means it's not a function because you have violated the vertical line test. You can only give me one value. Okay, so check, because you may have a situation where I put this X, where you have an open circle and a closed circle. You can only use the closed values, not the open values. Okay, just you never have more than one, and you can't use any of the open circle values. You can also kind of check this on your graph, because once you have your graph, that can match up as well. And again, you cannot report an open circle value. You can only report the closed circle values to say that they're actually the point on your function. Okay, anything else with piecewise functions? We'll probably only have you like 3 pieces, not 4. So just work through them. So then that brings us to analyzing graphs. So the more realistic one you're going to get is one like this, where you have arrowheads places. So why don't we make sure we can do the arrowhead one, and then we can talk about the other one too. So I say go over this carefully. So I had lots of people in one class just highlight areas where it's increasing and decreasing. That's not going to fly on the quiz. Okay, so if you lost your mind on the homework, don't lose your mind on the quiz. Okay, it's okay to highlight it so you can see it, but you have to still give me the interval notation. So when I say, where is this function increasing, that means I want to know, if you read from left to right, where the function is building. So I'm going to highlight, and then I'm going to tell you why I'm going to give you the values I'm going to give you. This is increasing. This is increasing. This is increasing. That's a good thing to focus in on, but you absolutely have to give me these values. Okay, so where it's increasing, remember at a vertex. And by a vertex, I mean a spot like this, 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 and this. At the vertexes, it is neither increasing nor decreasing. That is absolutely key. That is why when you identify where it's increasing, you have to not include the vertice x values. And remember, you're going to always be reading your x values. It is a really good idea when you get your little graph to come in here and label things. Okay, so always label the x first. This is -5, 4. Okay, that's going to be important. This is -4, 6. This is 1, -5. This is what, 6, 4. And this is 7, 1. Now, when you do these labels, it's always worth spending an extra second to make sure that you have done that as an X, Y. It is really easy just to flip one of them and it's going to mess you up. So take a second and make sure that you've done it in the correct order. Okay, so then get back to increasing. -5 to -4, reading my X's. It's much easier once you label them. Take a second and label it. It's hugely important. Okay, then you jump again. It's increasing from 1 to 6, reading the X values, and the X values are all of the first values. Then it's increasing again from 7 to infinity, reading the X values. Anybody have any concerns about that? So for those of you that just highlighted things, and there's about 3 of you on the video right now that highlighted things, are you able to bridge to also write it in interval notation, or do you need to ask me some questions? Because this would be a good time to go over that. So big takeaway, label your vertices. They're going to be important when you talk about increasing and decreasing. So let's do decreasing. So we'll do the same thing. I'll do it in orange. I'm going to decrease here. You're always going from left to right. I'm going to decrease here. I'm going to decrease there. Okay, I can't just have the orange. I have to have numbers. So look at the first orange. That's going from -infinity to -5, not inclusive. Then I'm going from -4 again to 1, non-inclusive, and then from 6 to 7, non-inclusive. And I'm saying non-inclusive because at the vertices, at those X values, it is neither increasing nor decreasing. Okay, and that's my orange, but notice I have to have the numbers. Okay, at this point, I would tell you to go in and label your X values, your roots. So this is -2, you only need the X's. This is 4, and that's it. Those are the 2 most important zeros. You're going to identify both of them in C, and we're done with that piece. Then it says, where is the function greater than 0? So greater than 0 means that your function is going to be living in this quadrant here and this quadrant here. So your zeros are going to be your landmarks. So from -infinity to -2, not inclusive, the function is in the pink above the 0. Then again, from 4, which is the root, all the way to infinity, the function is again in the pink. When you look at E, the difference is now you're allowed to equal the 0. The zeros are your roots. All that changes here is that what used to be a paren is now a box. What used to be a paren is now a box. And that's because you are allowed to equal 0. And you're equaling 0, your function's equaling 0 at the roots. And that's why I have my box. Okay? So keeping it going, where is the function less than 0? If you want to see where the function is less than 0, you're going to be in this quadrant or in this quadrant. Okay, so again, these roots or zeros of the function are critically important. Look where you're negative, from -2 to 4, not inclusive, because at -2 and 4, your function does equal 0. And the requirement is to be less than 0. Then for G, you're allowed now to equal 0. So you go from parens to boxes. Done. Next thing they ask you, where are the local maximum? They mean the vertices. So here is a vertice right here. Here's a vertice right here. They're maximums. I list both of them out as coordinate pairs. That's why they're in parens. The local minimum, they're going to be over here. That's a min. It's a valley, not a peak. That's another valley. Here's another valley. You list all of them. Is there an absolute max? And the answer is no. The reason why that answer is no is because you have arrowheads going up forever and ever. The function never gets to a maximum. The last question, is there an absolute minimum? And for an absolute minimum, you're going to look and you're going to say, yep, this is the lowest possible. So that's my absolute minimum. It's a valley. That's the lowest y of the entire function. And that's what I would report. Okay, so this is the one that you should be able to do, something like this. We're not going to have endpoints that are open and closed circles. We're going to have endpoints that are arrowheads. So focus on understanding this one. And we had other ones that we practiced for the 2.3 part 1 homework that I did in great detail in class. And I believe I posted the answer key. If not, we went over that in class extensively. Okay, so that's the whole review. Anybody have anything they want to talk about or ask about?
Dr. Riley,
Mhm.
for the second graph and for D where it says f of x is greater than 0, I thought that would mean that you just plot the points that are above the x-axis.
Yeah,
It's greater than
but you
0.
have to start at the x-axis and don't include it. That's why you have the parens.
Okay, so you wouldn't just plot all the points above the x-axis?
You can't, because there's an infinite number. So where would you start if you're going to plot above the x-axis? Would you start at 0.5 for the y value? Or would you start at 0.2 or 0.1 or 0.005? So you can't figure out where to start. So start at the roots and then don't include them. Use the parens. Because then you guarantee you can get as close as possible to the 0.
Okay, so if it has to be greater than 0, why
Yep,
would it start at negative infinity?
because those are the x values. So if you have an x value that's all the way down here, where's your function? My function is all the way up here. So my function is certainly above 0, right?
Okay,
Because when I say, so think about this, Nina, when we say the function has to be greater than 0, it means the y values are greater than 0.
okay,
And so it's asking you, tell me which x values generate a y value greater than 0. And the x values are the ones along the negative part of the x because of that arrowhead going up on the left quadrant.
okay. Oh, okay, okay.
Okay, and then so always use your zeros. Those are going to be your landmarks. And when they say if it's greater than or equal to, all of a sudden those 0 values that you had in parens are now brackets. So what I
Okay.
want you to get used to is only thinking this through once. You think it through, the next time the difference is that your 0 values are now brackets because you can equal the 0.
Okay.
Let me just grab this
Yeah.
chat too. Okay. So anybody else have anything? All right, so I have this. Okay, good, good, good. Okay, so do you think this helped? Are you starting to feel more confident? So you want to get a good night's sleep so that you can think this through. Okay, and then think about when you do increasing and decreasing, the turning points are your important features. When you do greater than or less than 0, your roots are your important features. Keep that in mind, and that will help you. Okay, these are all X values, only X values. When you go back over and check your work, make sure you're doing X values. When you get down to your local maximum and local minimum, those are coordinate pairs. So I have an X and a Y. Otherwise, everything is reading X values, and the X values are kind of telling you what's happening with the Y values, but you are only reporting X values. So big takeaway, how to help yourself be successful. When you get a graph, immediately label all the vertices. Then label your zeros. Having those landmarks are going to help you pick out these numbers a lot easier, and then look for the pattern. This is -5 to -4. Look where this one ends. This one starts here. This one ends here. There's a pattern. Okay, here's -4. Oh, here's -4 again. Here's 1. Here's 1. Here's 6. Here's 6. Here's 7. Here's 7. These numbers should repeat. So look for patterns. Math is all about patterns. And the difference between this and this is a bracket, a paren versus a bracket. The difference between this one and this one, parens versus brackets. Okay, look for the patterns. It'll help you be more confident, and you'll be able to be more successful. Okay, so we've done a lot of practice with this. You just have to relax and think things through. And when you are asked questions about parent functions, definitely help yourself out by doing a little graphing so that you're looking at a graph. Then you can more easily figure out the domain. Okay, don't think you have to do it off the top of your head. I'm never saying I don't want you to write anything down. I want you definitely to write things down. Okay, so this key is up for you. I'm going to put this video up on the same date, so the 12th. So I'll put the video up of the review. And then I'll send out an email saying that I've done that, because I told several students that I was going to post it for them. So, and I know other ones did not contact me, and I know they were not getting home in time to do the Zoom. So I'll put this up for everybody. Okay, so let me stop sharing here and see. Okay, I've got a couple of you that have stayed on. So what do you guys think? And are you guys, whose class are you in? Jackie, whose class are you in?
I'm in
Jackie?
Mr. Shock's class.
Okay, so do you think I've covered this enough for you?
I was a bit confused, I think, at the first part. If I can look at my study guide and I'll tell
Oh, I know who you are. You're my British friend.
you. Yes.
Yes. And Jackie, who are you? Jackie's gone. Jackie, remain anonymous. Okay, so look at your study guide and see if you want to ask me something.
I think the only thing I found a bit confusing was maybe the net change and identifying the domain. So so the first like few questions. So from question 5 to 8.
Okay, let me just get
and
this back up
question
again.
9. Yeah.
It's just going to take a second. Okay. Okay, so 5 to 8. So
Yeah.
for these, so were you on when I said you got to know these functions down here?
No, I wasn't.
Okay, so these are your 6 parent functions. So you want to know them, and you want to know if you make little adjustments to them. And so I would say memorize these 6 so you have an idea of what they look like. But then when you get to the test, you can do this kind of stuff. So we gave you these problems like this so that you had a method to deal with your domain and range. Okay, so I'm not going to give you a little T table. Like this is a T table over here. to the right, this is a t-table, but you can, you know, do your own little t-table so that you get this nice graph. Because you want to answer the question about domain from a graph, not just from your memory.
Okay.
Okay, so pick
Yeah.
numbers wisely so that you can get a nice graph. Because there's going to be a calculator free test, and that's why I'm saying pick numbers wisely. So I have some of these selected
So you have to
for
pick.
you.
You have to pick the root.
Well, in this situation, because f of x equals radical x, you're always going to pick x's, right? So
Yeah.
pick x's in this situation that are perfect squares.
Okay.
Like you're going to pick 5 and then try to figure out what the square root of 5 is, you know?
Yeah.
Like that's just too much. There's no need to do that. So pick good numbers. Just like when we're doing like this guy with the cube root, this cube root guy. Okay, you're not going to pick numbers that aren't perfect cubes.
Yeah.
So pick wisely. Always think about 0 because 0 works a lot and it gives you a landmark. You know, you want to, if you've memorized kind of the sense of what the functions look like, and then we change a little something, you'll be able to still identify the shape of the function based on what you know and your little table that makes a little adjustment.
Okay.
Okay, and then the other thing you were saying about is this net change. So the net change, if I say, what's the next net change from -1 to 4? This is what you're going to do. So follow this arrow down here. You're going to figure out what the f of 4 is, and then subtract away the f of -1. Okay, so if it says from this to that, take the last number first,
Yeah.
subtract away the first number.
Wait, can you repeat that? Because I didn't really get it.
Yeah, when
Okay.
it says find the net change from this
Yeah.
to this,
Oh,
Take-
okay.
figure out this first, the f of 4. So plug in 4 here, and
Yeah.
you get 13. So that's 13 minus, figure out the f of -1, take the -1, plug it in here, and you get a -2.
Yeah.
So 13 minus a -2 is 13 plus 2, which is 15.
Okay. Yeah, I see that.
And then for the next one, from this number to that number, do this number first, f of 11, plug in 11 here, do the math, you get 35. Minus, take the 6, plug it in here, you get 25. 35 minus 25 is 10.
Okay. Yeah, I see how to do that now. That's pretty easy when you
Yes.
think about it.
This should be low-hanging fruit. You should be able to definitely get this. Okay, just remember that the last shall be first.
Yeah.
Okay, and then be careful if you have a negative of a negative so that
Yeah.
you make it a positive. So just write out your steps so that you see what you're doing.
Okay.
Because this
And the
should be
last,
free,
yeah.
free money.
And the last thing I was having a bit of confusion on was finding the domain after you've made the graph. I think that was the
Okay,
only.
of the piecewise.
Yeah.
Okay, so when you do domain, so here's my function. So domain, I'm going to try to go to my furthest I can left because I'm doing X's, right? So I come down here, I see this arrow. So that tells me I went from -infinity. I hop
Yep.
on this arrow and then I say, okay, I want to continue doing X's. So I have an open circle here. Is something filled in? And the answer is yes. Look up here for X's. This
Yeah.
is filled in. So I can go right to here. Now start riding on this train. Okay, I get up to here because I'm at this X. I have a dead end. But wait, I can climb down here and get on this branch. That means I can follow this up here now. I'm over here. And now what do I want to do? Look below. Do you see how you can continue on your X journey here? And that goes forever and ever. That's how I'm going from -infinity to infinity.
Okay.
I'm just trying to ride the X train. So I can jump up and down because I'm really progressing along the x-axis by doing that. Okay, so to go quicker, I start here because this is the arrowhead going down. That's negative infinity. I
Mhm.
stop, but oh wait, I can still get on this x value. I'm coming here. Oh wait, I can still go down here and continue going to the right on the x. I get here. Oh wait, I can still continue on here, and I have an arrowhead. So I'm
Okay.
going from negative infinity to positive infinity.
All right, yeah, I get that.
And how are you with the range?
Yeah, can you explain the range too, just so I know that I've got it down?
Yep. So the range, you're not going from west to east. You're
Yeah.
going from south to north. So look for the furthest south. It's also this arrowhead. I get up here and I have to stop y values, but wait, these are y values that are okay. So that's how I'm getting from negative infinity to being able to equal 6. Okay, now I want to go up, but I have a gap. You see all this yellow? There
Yeah.
are no y values in there. So go to your lowest next possible level. It's here. This is -2 on my y-axis. I can equal that. That's why I have the bracket. Then if I go this way, I have a dead end, right? So go this way instead. I'm going this way, climbing, climbing, climbing. Oh, open circle. I look over here, there's no escape. I am stuck stopping here. So I went from -2 to 2, but I can't equal the 2 because of the open circle. Okay, so I say I have a function over here, but I have a gap. So I have to jump over the gap. And now I can equal this. That's my 3 with the box.
Okay.
Don't go this way, it's too short. Go this way, continue to climb. And this is where I have to end. That's a 5 value for y, and I have a paren.
Okay.
Okay, so your 2 gaps, this gap and this gap, are represented by this yellow and this yellow.
That makes sense.
Okay, so just try to follow the path and kind of, take notes as you're going to see where you have to stop. And always don't throw in the towel until you look to your right when doing your y values, and don't throw in the towel until you look up and down when doing x values, because you may be able to continue riding the x train if you just look at another piece of the function.
Okay.
Okay, so you should be good.
Yeah, I think I'm good now. Thank
Okay,
you.
well, very good. Well, I wish you good luck tomorrow.
Have
So
a
if you
good
can
night,
help
miss.
somebody in the morning, that'll only benefit you as well.
Yep. I'll definitely try and see if anybody can solve, see if I can learn better from it.
Yes, exactly. Well, very good. So have a good night, rest, and then hit the ground running and be successful.
Yep. Thank you, miss.
You're very welcome. Bye-bye.
Bye-bye.